Good evening, everyone. Today I am going to explain a concept called analogy between electrical system and physical system. For the workshop FDB 201X from Gokaraju Rangaraju Institute of Engineering and Technology, RC number 1080. My name is B. Vasant Reddy. If matter is stable, everything is dark. Our universe is dark. If matter is unstable, it shows the beauty of the nature. Contents of this topic: introduction, basics of electricity, basic electrical elements, basic physical elements, analogy, electrical elements and physical elements, electrical systems, physical systems, analogy between electrical system and physical system, conclusion. Introduction. Electrical engineering plays a major role in all the fields of engineering, and it advances all engineering fields. The problem with the electrical system is we can't see what is happening inside of it is through eyes. But if you create an analogy between electrical system and a physical system, we can understand the electrical system very easily because we can see the physical system with our eyes. Current. Current is a rate of flow of electrons or rate of change of charge through a cross section of the conductor. Voltage. General definition: voltage is a force that drives the current in an electrical system. Here, how to induce a voltage in a conductor? What is meant by EMF or a voltage? To induce a voltage in a conductor, we need three quantities. One is conductor, second one is magnetic field, third one is relative motion between the conductor and magnetic field. The first, we need to consider the conductor and magnetic field. Here we need our mind, a question should arise. How magnetic field inducing a voltage in a conductor? To answer this, consider a current carrying conductor. For a current carrying conductor, there is a magnetic field around it. But for a normal conductor, there is no magnetic field around it. Why there is a magnetic field around a current carrying conductor? Why not for a normal conductor? That is, I already told the current means flow of electrons. When electrons are moving, there is a magnetic field around it. That is, electron is a magnet when it is moving. From the above discussion, we can say that both are having the same property, that is the magnetic property. Now, I am explaining why we need a relative motion between the conductor and magnetic field to induce a voltage, even though both are having the same property. To explain it, consider a conductor. Conductor consisting of many atoms. Consider one atom and zoom it. Okay. The atom consisting of nucleus with protons and electrons are revolving around the nucleus. That is shown in the figure. Having a magnetic field of the electron as shown in the figure. We already know the moving electron is a magnet. Now you bring a magnet nearby the normal conductor. What happens is, the magnetic lines of force of an atom of the electrons will align with the magnetic lines of force of a magnet you are bringing nearby it. By moving the magnet, the electron which is in the orbit is trying to move in the direction of the magnetic field. Now, electron came out from the orbit. It is a free electron which is moving in the direction of magnetic force on the electron. The definition of the EMF or voltage. The force is required to move the electron in a particular direction. It is called electromotive force or voltage. So the electron is in conductor is moving in the direction. That means there is a potential difference between the 2 points. Basic electrical elements. Inductor. Inductor is an electrical element which stores the magnetic field energy and the current is passing through it. Magnetic field energy is half Li square. It doesn't not allow sudden change in current because voltage opposing the change in current. Induced voltage VL is equal to L into dI by dt. Capacitance. Capacitance is an electrical element which stores the electric field energy when the charge is equivalent on the plates of the capacitor. Electric field energy is half CV square. It doesn't allow sudden change in voltage because stored charges equivalent on the capacitor plates oppose the current. Capacitor current IC is equal to C into dV by dt. Physical elements. Mass. Mass is a physical element. It stores kinetic energy when it is moving. Kinetic energy Ke is equal to half mv square. It doesn't allow sudden change in velocity due to its inertia. Fm is equal to m into dU by dt, where v is the velocity of the mass, is equal to m into dx square by dt square, where x is the displacement. Spring. Spring is a physical element which stores the potential energy when it is compressed or expanded. Potential energy is P is equal to half kx square. It doesn't allow sudden change in internal force. Internal force is Fx. Analogy. Electrical elements and the physical elements. When mass stores kinetic energy when it is moving, when motion of velocity is 0, kinetic energy is 0. Inductor stores magnetic field energy. When electrons motion through it, and motion of the electrons is 0, magnetic field energy is 0. Both kinetic energy and magnetic field energy are due to the motion only. When motion is 0, both energies are 0. That is, magnetic field energy is analogous to kinetic energy. When you apply a voltage to the inductance, current starts increasing and the direction of induced voltage is opposite to the direction of the current flow. The voltage VL is equal to L into dI by dt. By seeing the current graph with increment in the current, the slope of the graph is positive. That is, voltage is positive. When we remove the voltage across the inductance, the current starts decreasing. Direction of induced voltage now is in the direction of current flow. That is, but by decreasing the current, the slope of the curve is negative. So the voltage is negative. Inductance changes its polarity, but the direction of current is same. When you apply a force on a mass, the direction of internal force is due to the inertia is opposite to the direction of motion, and we can see in the figure. By removing the force, what happens is the internal force direction reverses. The body is moving in the same motion direction. For the mass, direction of internal force reverses, but motion direction is in the same direction. Voltage force directions are reversed, but the current and motion directions are same. That is, inductor changes its polarities, mass reverses its internal force. The quantity responsible for creating the energy won't change its direction, but other quantity will. From the above discussion, inductance in the electrical system is completely analogous to mass in physical systems. We can take the scenario of static elements like spring and capacitance. Here some of the points which are related to the spring and capacitance, same as the mass and inductance. We can go through the slides, you can understand very easily. This is about the how the current flowing through the capacitance changes, but the voltage direction won't change. This slide is about by applying a force on the spring is compressed. The direction of motion and internal forces are shown in this figure. When force is removed, the direction of the motion is reversed, but internal force is in the same direction. For a spring, direction of motion reversed, but internal force is same direction. The current and motion directions are reversed, but the voltage and internal force is in the same direction for the capacitors and spring. From the above discussion, capacitor in electrical system is completely analogous to spring in physical system. Analogous quantities are voltage, force, current, velocity, charge, displacement, inductance, mass, capacitance, spring, magnetic field energy, kinetic energy, electric field energy, potential energy. These are the equations which are related to the electrical elements and the physical elements. The first equation is the Faraday's second law, second in electrical system, and analogous equation is the Newton's second law, where F equal to ma. The same way for capacitance and spring also. Next slide is about electrical system. Here are some of the points how an active energy is transferring in the electrical system by using the exchange of reactive power in between the inductance and capacitance. We can go through these points, we can understand how it is. Okay, here I am explaining by taking a system, by applying a AC voltage, having a capacitive element, inductive elements and active elements, and here the graphs, waveforms of current, voltage, of active, capacitive, inductive currents and applied voltage. If you take the reactive power of capacitance and inductance from this graph, we observe that now the capacitor's reactive power is positive, inductive reactive power is negative. That means capacitor is taking the reactive power, inductor is delivering the reactive power. When inductor is taking the reactive power, capacitor is delivering the reactive power. It means that capacitor can compensate the inductive reactive power or inductor can compensate the capacitive reactive power. In this way, we can improve the power quality of the system by putting the capacitive elements wherever the inductive loads are there. This slide is about the same, you can go through it. About physical system, by throwing a stone in the water molecules are moving up and down by exchanging the kinetic energy, potential energy and transferring the active energy to the endpoints of the pond. This is about the electric field energy, magnetic field energy. Electric field energy taken as voltage and magnetic field energy is taken as current having an angle of 90 degrees, V and I. And this is the total energy that can be seen by equation sin square omega t plus cos square omega t equal to 1. Conclusion. On the detailed discussion, the electrical systems and physical system both are analogous to each other. Now we can